Welcome back. The topic of this video is going to be planes. So let's start. So if I give you this equation here, 4x minus 2y plus 5z, and ask you what does this surface look like, or what does this equation represent? Now you can try and see what points satisfy this equation. Like for example, if you try the point 0, 0, 0, this point will satisfy this equation, therefore this point is included in this surface. However, if you try the point 10, 5, 0, it might not work. Yeah, so we know that this point is not included in this surface. So you can try this for many different points until you can get an idea of what type of surface it is, but this could be tedious, so we want to try and use a different way. So let us rewrite this equation in a different way. This looks like the dot product between two vectors. So this looks like the vector 4, negative 2, 5, dotted with the vector x, y, z is equal to 0. So this says that the vector 4, negative 2, and 5 and the random vector x, y, z are perpendicular because the dot product of two perpendicular vectors is 0. Therefore I know that this vector 4, negative 2, 5, which is going to look something like this, is perpendicular to the vector x, y, z. So we're looking for all the vectors that are perpendicular to this vector over here. And these vectors represent a plane. All these vectors are going to constitute a plane. So this equation here is an equation of a plane that has the normal vector 4, negative 2, and 5. Okay, let's have a different example. Let's say find the equation of the plane that passes through the point let's see, negative 3, 0, and 7, and has a normal vector (5i) plus 2j minus k. So I want to find the equation of the plane that passes through this point and has a normal vector 5i plus 2j minus k. So let's try and do this. So here's the 3D plane. The point negative 3, 0, 7 is going to be somewhere here. And the vector, this is 5, 2, negative 1. It's going to look something like this. And we're looking for this plane over here. And yeah, this vector is 5, 2, and negative 1. So let's draw a random point somewhere on the plane. Like say here, let's call this point x, y, and z. And let's draw a vector from this point here to the random point. So this vector, finding the vector between 2 points, is going to be x plus 3, y, and z minus 7. So this is a random vector that lies on the plane, and this is the normal vector over here. Therefore, if we do the dot product between this vector over here and this random vector, the product is going to be equal to 0. So let's rewrite this. It's going to be 5 times x plus 3 plus 2y minus z minus 7 is equal to 0. And in fact, this is the equation of the plane here. Of course, we can rewrite this as 5x plus 2y minus z is equal to negative 22, which is also an acceptable answer. So let me give you the general formula to find the equation of a plane. Let's say the plane passing through the point x0, y0, and z0, and has a normal vector a, b, and c. So the general formula is going to be a times x minus x0 plus b y minus y0 plus c times z minus z0 is equal to 0. And again, this comes from the dot product. Another acceptable method is saying ax plus by plus cz is equal to some random number d, and this number comes from when you multiply a times x0 plus b times y0 plus c times negative z0 and so on. So this is the way we find the equation of a plane. If you have any questions, please leave them down in the comment section below, and I'll be more than happy to answer them. Good luck.